I hope that you are good, well, and fine. Today we will be starting about the area of triangle using determinants, how we got a formula or how we got the relation in between determinants and the area of triangles, and then we will solve NCERT exercise 4.2. Okay, so let's see. So this will be our outline. As you can see, area of triangle, remarks, examples, and then NCERT exercise 4.2. Okay, so as you know, all know from the geometry, that if you have a triangle with vertices, suppose your triangle is like this. Okay, your triangle is like this. So this is just nothing, x1 y1, this will be x2 y2, this will be x3 y3. Okay, then you will have your area using this, and this expression will come from where? As you can see, if this is your Cartesian plane, you have these. Okay, like this thing. Now what will happen? You will have parts of what can you say is what can you say trapezium. As you can see, trapezium, you will see a trapezium forming. So one trapezium is this, yes, another is this one. Okay, clear. And another one is this one, this complete. So this complete or the purple trapezium area will cover a whole. Now these two green areas, these areas will cover these part. So if you subtract the purple area, okay, you find out the purple area and then minus these green areas, you will left with the triangle area, and then from that you will get this as your expression. Let me give you what do we mean by trapezium area. Okay, so area for the trapezium we all know is what? Trapezium area, let me write it here. Okay, so trapezium area. Okay, so trapezium is like this. You all know about trapezium. Okay, trapezium structure, the figure looks like this thing. You have two parallel sides, say this and this one. So area will be half of sum of parallel sides. Sum of parallel sides. Okay, sum of parallel sides multiply with height. How you got this formula? Quite simple. You just draw these lines, parallel lines. These will be parallels, okay, and perpendicular to it. As you can see, this is just nothing but your what? This is just nothing but your as you can see parallels. Okay, and this figure inside is a rectangle, and this area will be what? As you can see, this area will be length into breadth, which is this L into B. Okay, B, if B is say this B not say this is H, this is your L up till now, up to this point. Okay, now what about these areas? So area for this triangle, area for this triangle will be what? So whatever the part it is, so say A part, so this will be half into base which is A, base into height which is H, height which is H. Okay, simple. Okay, now for this is B, suppose B, and the height remains the same, you will have B, as you can see. Okay, so what you got? So you have half BH, you have half AH, and plus you have this inside rectangle area which will be L into H. Now take half common, taking half common and H common, you left with L A. Okay, L A L A H, L A H half you will left with this thing, half LAH. Okay, simple. So what? So first of all, if you try to see, if this is L, if this is your L, and this is also your L, yes, you will have quite a nice rectangle with a breadth or this side as H. Okay, so L, H, H. So area will be L into H. You all know area. Okay, length into breadth. Simple. Quite simple thing. What is happening? And you just added this area and this area. You will have the whole trapezium area, which will be like this. So this is just nothing, but as you can see, A, and this is just B. Okay. Now what is happening? As you can see, oh sorry, this will be 2L, not L. This will be 2L. As you can see, I took half common. Now, as you can see, I can write this 2L as L plus L. Okay, quite simple. And this A plus L plus B will be this parallel side sum. Okay, so one parallel side. So I am saying this whole parallel side as L1. So this will be L1. And this is what? This is also of length L. I am saying it is L2. L2. So what is happening, as you can see, we are adding sum of the parallel sides. Okay, what we are doing, sum of parallel sides, half into height. Okay, so that's why we have area of trapezium like this, half into sum of parallel sides multiply with its height. Simple. So I hope that now you won't be having any difficulty memorizing this area of trapezium. So this concept will be applied here. So you will get your expression. I'm not going to drive it as we are learning about determinants. Not we are not talking about the coordinate geometry. Okay. So I'll just give you the hints. That's it. So these are the hints. Simple. Now what? Now this expression written over here can be reduced to determinant form. Okay. So how we are going to reduce it in determinant form? As you can see, if determinants like what, if you try to recall the determinants, what happened in determinants is just simple. So a11, a12, a13, a21, a22, a23, a31, a32, a33. So in determinants, you all know, we try to expand according to a row or column or whatever you chooses. Okay, suppose if you chooses this row, so you will have your signs like this. Okay, so this means a plus a11 minus a12 plus a13, and then respectively you eliminate the respective rows and columns and then multiply the corresponding elements. Okay, so as you can see, what is happening here? Quite simple. Suppose these are the some row or column elements. Okay, and now what is happening, this just y2, and this can be reduced to 1 multiply y2, 1 multiply y3. Okay, this is kind of determinant form. Yes, so one form is nicely written here. So now what you will do, if you try to find your determinant using your column 1 like this, so you will have what, so you will have to choose what you can say, so plus minus plus. So plus x1, as you can see, now what entries you have to eliminate, this, you will multiply y2 with y1, y2 minus y3 you will have. So nicely written. Okay, you got this thing. What about this? Let me write it over here, x1 minus x2 plus x3. For this you will get y2 minus y3. Okay, for this what you will get, so eliminate this row and this column, you will have y1 minus y3. Simple. And eliminating, now for x3 you have to eliminate this column, and this row you have y1 minus y. Now as you can see, what that here we use plus, yes indeed, but one thing is very clear, that here y3 minus y1 is happening, here y1 minus y3 is happening. So what I will do, this minus will be multiplied inside the bracket, so it will be plus and the sign will now change. So now it is of the same form as written here. Okay, clear? And we already have a half written over here. Simple. So your form for finding the area of any given triangle with vertices, obviously we want to know what will be our vertices. Then you can directly find your area by using determinant method. Okay. So if you suppose that can we make another form, let us try to build another form. Suppose if you try to write it like this: x1 x2 x3 y1 y2 y3 1 1 1. Then what will happen? Okay, let us see. The expansion will be, okay, so it will be plus minus plus, so plus minus plus, same thing is going to happen in terms of sign. Now what will happen? So eliminate these, you only left with, so y2 minus y1, okay, y2 minus y3, sorry, y2 minus y3. Now eliminate what? Eliminate x2, and this you only left with, so y1 minus y3. Okay, so far so good. Now for this you have to eliminate this, you left with, so y1 minus y2, y1 minus y2. Now this I am going to multiply inside, you will have y3 here, y1. So do we get the same expression? As you can see, yes, we are getting. So please do what? Please do the, you can make another form also, but that form must exhibit the same expression as this. Okay, then only it is very useful. As you can see, you saw two forms, one is this one, another is this one, both giving you the same determinant, both giving you the same determinant. Okay, so write or memorize any of the form. You can memorize, please put always half. So x1 x2 x3, quite simple to memorize, y1 y2 y3 and 1 1 1. And another form, this will be same as x1 x2 x3 y1 y2 y3 and 1 1 1. Simple, just clear. I hope that it is clear how we got the area of triangle using determinant. Okay, now let us move to the next. Now some remarks. Okay, so since area is always positive quantity, yes, but in determinants we always saw what that determinants could be negative also. So since area is a positive quantity, we always take absolute value of the determinant. So whatever the determinant answer will be, please take it in absolute value. Okay. Now, if area is given, use both positive and negative values of the determinant for calculation. Suppose area is given, then you have to use both positive and the negative values of the determinant for calculation. You will see what this second point says. If when we are doing the questions, you will see that what actually these remarks are saying to us. The area of triangle formed by the three collinear points is 0. That means you have 3 points which are collinear. Collinear means they lie in a straight line like this. Then the area will be 0. As you can see that it will be 0. Yes, indeed. Okay, clear? Okay. Now I hope that these 3 points are somewhat clear to you. Okay, not completely. Completely will be cleared if you see the exercise. You will see. Okay. Now, for example, here. Okay. So you have to find the area of whose vertices are 3 8 minus 4 2 and 5. 3, 8 minus 4, 2 and 5, 1. So quite simple. x1, y1, x2, y2, x3, y3. So you have this. So x1, I'm going to write in this form. So x1, x2, x3. So x1, x2, x3, y1, y2, y3 and 1, 1. Just use this. This will be what? Your plus 3, plus 4. Because of minus and minus 4, you will have plus 4 and plus 5. Simple. This will be 1. Okay. So, okay. Simple. Now bracket, bracket and bracket. Okay. So far, so good. What will be the next step? Quite simple. Eliminate this row and column. You will only left with these. So multiply this 2 with this and multiply this one with this one. So 2 minus 1. Okay. So far, so good. Now what? Eliminate this and this row. What you will have? You will left with these entries. Now multiply this 1 to 8, this 1 to 1. You will have 8 minus 1. Okay. Clear? Okay. So far, so good. Simple things happening. Nice thing happening. Now eliminate this row and column. You only left with these. So this will be 8 minus 2. So this will be just 2. Sorry, 1. This will be 7. This will be 6. Now this will be just 3. This will be what? 28. And this will be 30. This will be 30. If you add these, what you will get? You will get 31 and 61 in total. This will give you 61. 61. So your answer or the area will be this unit square. Okay. 61 by 2 unit square. Okay. If I did some thing wrong, please verify that you are getting this area or not, or indeed that this given thing 61 by 2 is the correct answer or not. Okay. I hope it is clear to you. Now find the equation of the line joining A, B using determinants. Okay. You have to find the equation of the line joining A and B. Okay, so far so good. Now what? And find K if D K comma 0 is a point such that the area of a triangle is ABD is 3 square units. Okay. So first part of this question, what is saying? What it is saying is that we have to find the equation of the line joining A and B. Okay, you have some point A which is 1 comma 3. You have another point B which is what? 0 comma 0. So you have to find this equation. Okay, clear? Okay, so how you are going to find it? So as you just saw that whenever you have what? Whenever you have what you can say is quite simple. Okay, so how you think that you can find this equation of the line joining A and B using determinants? As you just saw that if you have 3 points collinear, then its determinant will be 0. Its determinant will be 0. Okay, we will use that. Okay, we will use that information. So we have 1 point. 1 point is very clear. 1 point is 0, 0. Another point is 1, 3. Can you find another third point? Can you find third point? So if you try to see the third point, what I will say, let's say the third point is some x and y. Yes, third point will be x and y. Now I know that these 3 points are collinear. This means the area, this thing will be equal to 0, as you all know. Okay, so this means, so what I will do, so I will just do x1, x2, x3, y1, y2, y3 and 1, 1. Okay, now I will find this. Half of this will be, let me write it over here. Okay, half of, so what in terms of what I will do my expansion, in terms of this column 1 I will do my expansion, as this is 1, sorry, plus minus plus. Okay, so this will be vanished, this will be vanished, as because of it it will be going to multiply with 0. So you are only left with this thing. So now expansion, you only left with this. So 3x minus y, okay, will equals to 0. So from this what you get is quite clear. So half of 3x minus y will be 0. So this means you will have 3x minus y by 2 is equals to 0, will be what? Your equation, or 3 by 2x is equals to y by 2. So if you put x is equals to 0, if x is 0, then y is also 0. So 0 comma 0. Now if x is what 1, if x is 1, if x is 1, what you get? Y. So x is 1 means y by 2 is equals to this, and y is equals to just 3. So x is 1 means y is 3. So you saw that you verified your equation also, that if x is 0, y is 0, this means 0 comma 0. If x is 1, y is 3, 1 comma 3. So this is your equation of the line which joins 2 points 1 comma 3 and 0 comma 0. Okay, clear? So what we have used? We have used, whenever you have 3 collinear points, the triangle area or this determinant value, y1, y2, y3 is 0, 0, 0 is equals to 0. Okay, so we already know 2 points. We already know 2 points, say AB. Okay, we already know 2 points. AB will be x coordinate values, and CD will be the y coordinate value. Okay, sorry, it is, these will be 1. And in place of this, we will choose any third point. Say this is my any third point on this line, and that point, what I will be calling x comma y. So this will be just x, this will be just y. Now just solve it, you will get your equation. That's it. What we have used is quite simple. Okay. Simple. So you just verified and also got your answer. So your equation will be what? Y is equals to 3x. In other words, y is equals to 3x. Okay. Okay. Now what? If this is my b, this is my a, 1 comma, and there is another point D. Say D is this point. Okay, D is what? Suppose somewhere here D is this. So D point is k comma 0. This is 0 comma 0. Okay, now you are having now a triangle, but this triangle area must be this thing. This triangle area must be 3 square units. Okay, so this means the value, let me clean some space. Okay, now what? Now what is happening is quite simple, that you are given 3 points, and you know, using these 3 points, the area of the triangle is already given to you, which is 3. Okay, so this means area of this triangle, in terms of determinants, I can calculate by using this thing. So this will be x1, I am saying x1 0, x2 1, x3 k, y1 0, y2 3, and y3 is 0. Now 1 1 1. Simple. Okay, now just evaluate. Quite simple. I will be evaluating using column 1. So plus minus plus, first two things will be eliminated. You only left with plus one thing. So plus 1. Now eliminate this and this. You have 0 minus 3k. You only left with what? As you can see, this will be 3. This will give you 6. This will be what? As you can see, is minus 3, minus 3k, minus 3k. So this means your k value will be, k must be minus of 2. K must be minus of 2. Yes, k must be minus of 2. So value for k will be minus of 2. Okay, so let me once again verify. So you have what points 0 comma 0, you have 1 comma 3, now you have minus 2 comma 0 or 0 comma minus 2. Yes, you have minus 2 comma 0. Okay, you have minus 2 comma 0. Now let me just verify using the determinants concept that what you are having. So 0 1 minus 2, 0 3 0 1 1 1. Now I will be expanding using R2. So this will be minus plus minus, as this position is 2 1, which is odd. This will be 2 2. Okay, so far so good. Now half, this will be a minus 0 plus 3 plus sorry, minus 0. This will be directly eliminated. Now you are only left with this. So eliminate this row and this column. You left with these entries. So 1 multiplied with 0 give you 0, minus of this multiply this will give you plus of 2. This will be what? As you can see, this will be 6. 6 by 2 will give you 3. So your output is 3. That's what you want. So you evaluated your value k is equals to minus 2, which is correct value. Okay, we also verified that. I hope that it is clear to you. Now let us move to the next problem or exercise. Here we started our exercise 4.2. Okay, so 4.2 exercise, the first question, we have to find the area of the triangle with vertices at the given points. Okay, so we are given vertices. Okay, so let us solve. Okay, so for in case this, so it will be half of 164 0 0 3. Okay, so 1 x1 x2 x3 y1 y2 y3 and 1 1 1. I will be expanding using R2. Okay, here. So this will be minus 0 plus 0 minus. This will be directly vanished. You are only left with minus 3. Now what you have to eliminate? You have to eliminate this column and this row. Now so 1 multiply with 1 minus of 6, you will have, this will be minus 5 minus 5. This will be just 15. So it will be 15. 15, and the final answer, the answer or the area will be 15 by 2 square units. Okay, clear? So 15 by 2 square units. Okay. Okay, now in the second case or in the second part, what we have to do? So in second part, quite simple. This row will be 1 1 1. So x1 x2 x3 y1 y2 y3. Okay, so this I will be expanding through row 1. So plus minus plus. So plus 2 minus 1 plus 10. Now eliminate this. You have 1 minus 8, 1 minus 8. Now eliminate this. You will have 1. So this will be 7 minus 8. 7 minus 8. Now eliminate this. Eliminating this, what you will have? 7 minus 1. Simple. And this will be minus 7, and minus 7 means minus 40. Minus of 40. Okay, this will be minus 1, this will be minus 1, this will be plus 1. The output will be plus 1, plus 1. This will be 6, this will be 6. Okay, this will be 6, and this will be 60. Okay, 60, 60. Now you just have to add, as you can see, 60 minus 14 will give you 46, I think. 46, yes. If you add, yes, 46, and 46 plus 1, 47. So 47 in total, the area will be 47 by 2 square units. Okay, simple. Things are very simple. You have to what? Just put the x1 y1 x3 x1 x2 x3 y1 y2 y3 and 1 1 1 in this specific form to find your area. Now for this, minus 2 3 minus 1 minus 3 2 minus 8 1 1 1. Now expand using what? R1. So this will be plus plus minus plus. So this will be what can you say is minus 2 minus 3 minus 1. Okay, now eliminate this. What you will have, 2 minus minus, so it will be plus. Now in this case, eliminate this. What you will have, minus 3 and minus minus, this will be this. Now eliminate this. You will have minus 3 and what, so this will be minus 3 and minus 2. Okay, simple. This will be 10. This will be plus 5 and okay, and this will be minus 5, minus 5. Now this will be minus 20, minus 20. This will be minus 15, minus 15. This will be just 5. Okay, just 5. If I'm doing anything wrong, any calculative part, please do verify by yourself. Okay, in this case, so minus 20 and minus 20 will give you minus 40. So this will be minus 40 by 2. And this will be what, just minus 20, but area must be positive, so you have to now take the absolute value, which is 20. So your area in this case will be this. So if you recall your remarks, so that second, I think the first remark was, or the second remark was talking about the absolute value. So the determinant can give you the negative output, but you have to take, in case of area, you have to take the absolute value. So this will be your 20 square units. Okay, simple, easy problems. Okay, so that's it from our side. So we will be stopping here. We will be covering the remaining problems of this exercise 4.2. Okay, so thank you.